Hey crew, here Andy again. Today we're going to keep talking about how to build better software, and in this episode we're going to talk about SQS. So let's start first. What is SQS? Well, SQS is a distributed queue service that is provided by AWS, and basically it's just a platform where you can put message and just wait until someone or something just can consume it. SQS can be a standard or can be a FIFO. So the difference is oh my god, I need to learn to modulate better. The difference is that on FIFO they guarantee that the message are going to be delivered in the same order that they are routed to the queue. On a standard, they are telling you that they are going to do their best effort in order to deliver that order, but it's not guaranteed. Therefore, a message can be processed multiple times. Why not? So we are going to see today how to work in the serverless framework, and also how to get advantage of this queue service. So this is what we are going to build today. So far in the previous video, we built this part. We already have an API gateway, and then we also have Lambda that serves as a GraphQL server, and we have our DynamoDB where we store orders and user. So we're going to continue that. So we're going to increase that to create a string, which is going to listen for changes in the orders table, and then it's going to put those orders into the queue to be processed by another Lambda, which is going to be a worker. So we're going to see the advantage and disadvantage of this method and how to improve it even better from that. So let's begin. The difference between the previous video is that I just added a few other stuff. For example, I add a mutation, which means that right now we just can create order, and we just pass an email and a comment, and this is going to create a record in our orders DB. So that is the part that we are going to work today. So we are here, and let's create this process order Lambda. But before, I just wanted to notice that this is kind of getting complex, right? We are hard coding a few stuff here and there, and I want to take the time, since we are on early stages of this project, to make things a little bit better and take advantage of all the features that the serverless framework provide for us. And one of them is that custom variables in here that we just can use to create a few key values storage that we can use all around. So I'm just going to guide you how to go through this. For example, I was having the problem that I create a few sessions and a few videos, and I realized that I needed kind of a prefix for each. So that is easy to achieve. Sorry, you can create a prefix. Let's say for this session, I'm just going to call it SQS session, and then I'm just going to that these table names and the table user that's hard coding here and there. I'm just going to fix that. And so let's create also a table users and our table orders, and let's create how this is going to be called. So I just want my table users to be called that my prefix that I just created here, and also then it's going to be called users. And so let's make this dynamically. So we can say that this is going to be like self custom, so I can refer to this. Then I just can first refer to the stage. Then we do basically the same, but right now we refer the prefix. And lastly, we just put the name on that. So let's use this convention for also the orders. So nice. So since we changed this, so let's substitute all in all the places where it should be substituted. For example, in the resources for the user table, we just can say that now it should work fine if we substitute this for this, and then just change this for orders. So we just have one single source of truth instead of being hard coding that everywhere. So in here as well, we just can change it for, let me just change user, this is orders, and also for users. And let's see in our resource part of the project what else we should have in here. So the name as well, table name is going to be called orders, and this one is going to be called users. So this means that I just need to rebuild my project again, because I make a lot of changes on the resources, and this can create a few conflicts in here. So I'm just going to remove the current project that I have. I'm going to rebuild this and come back. So after some minutes, our project is deployed. Now you can see that our database has the stage and the prefix and the name of the database attached to it. And also we have our new project deployed, in here, our function here. So, and also I already create two orders for this. Let's see, for Andy, one for Taco. So that's okay. So that we are ready to move on with this. So let's see what is the other part that we need to create. Okay, we need to create this Lambda function that is going to listen for streams and for changes into the DynamoDB. Okay, so first thing first, let's define how our queue is going to look like in our resource bar, in our serverless YAML file. We just need to create this space for our queue definition. we are going to say it's a type of SQS queue, and our queue name, we need to define our queue name. So I'm just going to put in here, and we're going to tell that this is going to be called the thing is in, let's put it in custom stage and say also the prefix that we have in here. And lastly, let's call it queue, whatever. So let's come back to this. So a queue have a few properties that we need to know about. And in the first that we're going to mention, there are a few more others, but these are the more important. The message retention period is that how long is going to last your message into the queue. So the minimum is 1 day, the maximum is 40 days. Their default is 4 days. So take in consideration that as long as the message is on the queue without being processed, and the more that you're going to be charged for. So be aware of this data. This one is very, very important, the visibility timeout. When a message is picked from your queue, it's going to be invisible for some time. So after that time, if there is haven't been any answer from the worker or the consumer, how do you want to call it, acknowledging that they already processed the message and they delete that message, that means that the message is going to appear again. It's going to be available for someone else to pick it. So this one is very, very, very important. That can be from 0, but they don't recommend it to 0. So the minimum should be something like 30 seconds, which is the default, up to 12 hours. So that is kind of nice. And the maximum size of each message, remember that we in here are going to process text messages. So they can be JSON file, they can be XML file, they can be plain text file, whatever you want. And you also can specify the size of the max size of this. And the receive message wait time in seconds is that when we ask for a message, how long are we going to wait for more message before returning that to the easy to instance, to the Lambda function, to whatever is going to try to pulling message. So let's create that parent. How here probably you notice that we are not triggered because that is not possible, because queue are always pull based and not push based. So an example of a push based product would be like Dynamo and strings, Dynamo strings, Kinesis string or SNS. But for pulling, we need to be asking: is there something for me? 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 Yes, okay, I will take it. I process them again. Is there something for me? Is there something for me? Is there something for me? So if you have used RabbitMQ in the past or Kafka, you probably know how this thing works. Otherwise, you just keep asking for something over and over and over until you just get something. But also consider that this also process order. This Lambda function is going to be called like the process order, like handler, and the event for this is going to be a string. And let's say the starting position is going to be the latest, and the bash size on this is going to be 3, and the type is going to be a DynamoDB because it comes from Dynamo, and the RNN, we need to get the RNN. It's going to collapse this and also this, and we need to get the RNN of this service that we're going to create in here. But since we don't know that yet because that is created dynamically, we just can use some syntax for Cloudformation Template that it looks like this: get add colon, and we're going to get the name of this service that we're defining here, the orders table, and we're going to get the string RNN. Okay, so we need to make another modification here in order for this table to support streams. So it's two line stuff. We need to add a string specification, and we're going to say that the stream view type is going to be a new image. There are different types of this. I will put this on the comment for you to see. There is also string horizon, and there are also a new and old image. But I'm just telling here that I just care about the new image when something happens. So let's see exactly what this means. Let's create this handler function first. This is strict, and I'm just going to paste this part in here so you just don't see me typing. And we're going to say that we need this other two stuff, and we need to configure this one. I forgot to pass these variables in here, so let's do this. We're going to say that, and the environment variables that its function is going to use first, going to use the region, and the region should define the region here. Let's put it in here. Is going to be like up. It's going to be like a self provider at the region. So this means that we can pass it here and say that custom that region. And also we need to pass, what else are we going to pass in here? We will need in the future that SQS URL. And we can say that the same thing, that is going to be custom the SQS URL. We haven't defined it yet, so let's put it in here so we don't forget about this. And let's come back. We are going to come back to this later. So let's go again to our process order, and we say that we instantiate our AWS SDK and we create a new instance of SQS, and let's see how this is going to work. We also need to instantiate Dynamo as well. Let me do this. Dynamo DB will be a new AWS DynamoDB. This is document client. Good. Now let me also change. Nice. So let's come back to this part in here. Okay, so remember that the string is going to come in the event object that we're going to receive in here. So it look like this. So we care in here about this new image object that we come here. So we're going to get the records and the first item that we get, and we're going to finally get the new image. And also start seeing that this is going to be a problem. This is not on JavaScript based. I mean, it should be create add and the record here, not create add an object, because this is the way that Dynamo returns the data from the stream. So I just want to teach you how to solve this issue that we basically have in there. So let's say that our record is going to be event.records with capital S. And since this is going to be, this can be, we need a way to map it. And no, you know what? We cannot map it because into each one we need to call a promise. The record that event name is equal to insert. And let's see why I'm doing this. There are a few types of events that are insert, there are updates, and a lot of them. I think there are like 5 of them. So if we just come to our map, you notice that at some point we're going to update the order when it's done. So that also is going to trigger the string. So this means that this Lambda is going to care about the update. So this should not do anything at all if the event is other than insert. So that's why I'm putting this part here. And lastly, we are just going to do our, let's say, send message to SQS, and I'm going to put the, let's call it order, and let's define here like our order is going to be that record, like DynamoDB, like a new image. Let's come back again to our stuff and notice that I care about this part. So let's now solve this problem. We're later going to define this. You know what? Let's do it right now. We're going to be equals to a pipe of send SQS message. Also, but I need send SQS message, and I need as well create SQS message. And let's define these two here. I'm just going to say that. So okay, so and now I just create these two functions in order to separate them so they seem more elegant. So I am going to require install and save dependency. It's going to require Lambda, and one that is installed, we're just require here. We're just going to say like pipe from require Lambda. So good. Now this looks good. Let me check. Let's check. Okay, so let's also put a console log in here that putting order ID into the orders queue. Nice. Now let's solve the problem that I told you with the Dynamo object. So what's going to happen here is that we need to get the translator, and we can Dynamo, let's call it DynamoDB translator. It's going to be a DynamoDB.get translator. Okay, so this is part of the document client API that they provide for us, the SDK. So we can say also that our format is going to be like DynamoDB service, like API, like get item, output, members, item. I know this is horrible as fuck. Well, this is what it is. And lastly, we need to come back here, and before we start using our record that new item, we need to tell that our record that DynamoDB that the new image is going to be equal to our DynamoDB translator. Just translate output, and we're going to pass our record that new image, and we're going to pass its format that we have in here. Okay, so that should be it. That should do the trick, and this should be going out with this. Let's deploy this. Let's deploy. Well, we can't deploy it yet because I forgot to define the queue URL. So the queue URL is going to be used when we create a message for the SQS. So let's come back to our, so take that also there's an error. SQS, our region, our account ID, and the name of our queue. In this case, is this SQS order. So now we are okay to deploy this. So let's deploy. And also we need to give them the permissions for accessing to the queue. Right now. That should be it. After the magic of stop and play, and let's see how our resources were created. If you come to the SQS service page, you will see that our queue was created with our retention period, max size, and all our configuration stuff are in there, and also the type. And we need to see if this works. And in order to do that, let's see our logs. We can say that escalate log and function is going to be stale, but I think it's not going to work, or yes. Okay, let's put some base in here. I test a few example of that. So let's see how this is going to work. I'm just going to add another record to the database, and let's see how our function react to that. So okay, it was added. So yes, after a few seconds, we can see that our order is into the queue as we specify on the logs. And let's look for it in this putting order in the queue. So let's see if everything went well. We should be able to go to say this part. We should be able to go to our manager and see, yeah, fuck yes, there is one message here. Let's try to see it. You can start polling message and you see more details. There is your order, taco meat grass fuck, and our ID. And so that is super cool. So let's see. We already have this part built, the gateway, the stream process, and we have the order place on the queue. So fucking sorry for that. Now we need to create our worker, who is the one who is going to consume all that message in there. Let's see how we can do that. So, okay, so we are going to come back in here and let's create our worker. So the way that it's going to work is quite different. If you see here, I put some kind of CloudWatch icon and a wash in here, because as I mentioned before, is we cannot create a Lambda function that, like the others for the events, can listen for an event to happen. Basically, we need to make a schedule. We need a way to see, okay, each 5 minutes, each minute, each 1 hour, each 10 minutes or so, run this function and run again. And if we come here and come to CloudWatch, where the fuck is CloudWatch? Okay, it's in here. You can see that we have logs and we have events. So we just can create a custom event for us. So let's see. We don't have any yet, but we're going to create one. Let's come back in here and see how we just can create. Let's define our worker. Our worker is going to be handler, but our functions is going to be worker. It's going to be handler as always. And the events, in the events that this is going to listen for, is going to be a schedule. We're going to say the rate. For the sake of this example, this exercise, we're going to put 1 minute. Each 1 minute, just run and run and run. And I always recommend to put a description here. So let's put runs. It runs each minute to pull data from the SQS queue. Okay, and this is going to need a few other info. Let's say it's going to be environment. Let's see what this is going to need. And this, according to our diagram, this is going to need to write to Dynamo. This is going to need access to pull data from the queue, so it needs the queue URL. And lastly, it's going to need a region. So yeah, that will be good enough for us to start putting stuff in here. So the first thing it's going to need is a region. So we can say that self.custom our SQS and our orders table. So that should be enough. Now, let's see how we can create our function. It's going to be a worker. Yes, good. So we are basically so these are going to be all our dependent. So we're going to say, okay, we're going to start pulling from, let's put in here the queue URL, and we're going to say that our queue, sorry, is going to yield. Let's listen for queue get message from orders queue, and we're going to pass the queue URL. So let's define this. We're using the same thing that we use for the other. So yes, this is good enough, and it looks looking good. So what's going to happen here is that we need to iterate over the order of queue that message from now off. Okay, but this might be null, so we need to do something like this: is nil. If this is null, if queue that message is null with an s little, we just return, and we can say something like console.now message to process at date at now. So I'm missing this part here. Good. And now we just can create this is message, this is not order, sorry. So we can say, okay, our order is going to be the parse JSON.parse of the body of that message. I'm going to add an example of how a SQS looks like, and you can find out examples in there. In fact, let's create it. It's going to be a file, and it's going to be SQS message.json, and I already have a sample around. I'm just going to put it here so you can see it later. So we are interested about this body, and it's in the message in the record that is on the body here. Okay, so we just came back to our worker and see, okay, and we need to assume that we're not going to process any order here. So I'm just going to add a complete, assuming that this is our process. So date that now, and order that maybe update add date that now as well, because we're going to have another more status in the future. So we're going to say that status completed. Good. That should be good enough. But right now, after we process our order, we need to delete our message. We have to acknowledge that we did all our stuff that we need to do in there. So we're going to need some data from here as well. So we need the receive handle, and it's going to be on the message that the receive handle. If we come back to the example that I have in here, you can see that I need to return this hash that you see in here in order for the queue to know that I have the right permission to do that. So also, this is an async operation, so let's think how we're going to do that. You know what? Let's do something quite, let's say like orders, and this shouldn't be a constant. So we can say that our orders is going to be equals to orders and concat, and let's pass an object here. It's going to receive the order that I just processed and the receive handle, because I'm going to need this later. So what we're going to do is that we're going to process all our orders. We're going to save it in our orders array, and after we're done with all that, we are start acknowledging and saving the stuff in the database. This might not be a production ready approach, but for the sake of the example, this would work. I think this pattern will work well here. So let's see. So for let, just going to need this object that we are passing here, orders handle here of orders. Let's put it console log, and let's say that updating DB records, and we just come back and assign the values to this, and this is going to save the stuff to Dynamo. And lastly, we need to delete all our records from the SQS. So this is the way that we do it. We just create a configuration params object that we're going to pass to the delete message. We're going to pass the queue URL and the receive handle that we just got in here and receiving here. And let's put some order here. And if something goes good, we just can pass the result error in here, indentation bad found 6. So this means that I need more indentation here. And this means that we are logging that everything went good. So let's see how that would work. Let's find out which permissions I need in here. I need the receive message from the SQS, and I also need the delete message, and lastly I need a put message also. Let's see if I have them all. So yes, it looks like I have all the SQS permission, and I have, so we should be ready to go. Let's deploy this beauty. Okay, it's done. So first thing first, let's see our CloudWatch. Let's refresh this. Okay, nothing happened here. Let's see our rules. Okay, as you can see that we just create a rules that say that fixed rate of 1 minute, we're going to execute this Lambda function that is going to be our worker. So let's see the logs for that function. If we just come here and see the logs of our worker, I assume that it's been working. Yes, it is. So let's starting from scratch. There is no message to process. Let's just save another. I don't know. You know what? Let's clean our database so we can see that everything is working as it should. Action delete. So okay, so let's put one element in our database. So good, it's put in here. Let's wait for this to realize it. If that is on the queue right there. Yeah, start polling, no message to process, so we need to wait 1 more minute. Let's just make sure that our message is on the queue. If we refresh this, yes, it is in here. So let's wait for this to come again. Okay, starting to come. Oh my god, I fucking hate the wait so much. Yes, so we start polling or the NDB record, so we are deleting from the queue in here, response. So if everything went good, we need to go to our DynamoDB, and it should have the event process, and it is completed. And the status, so yeah, it's working fine. So let's add a few more orders in here. Just going to add one for Andy, and I just want to add for Lele, and I just going to add one for Nacho, and I don't know who else, Karen, and Santiago. So good. So if we come back here, we see that they are already being processed. So this is working fucking fast. So good. It's working really good. Hell yes! Look how all the order has been processing. Okay, nice. So after a few seconds, we can see that all our orders but one are completed. So the next one is going to be completed soon. So let's see what is happening in here. Let's go back to our definition for a second and see. Okay, we have one Lambda function that run 1 minute. So hey, is there something for me to process? Hey, is there something for me to process? Hey, is there something for me to process? So that is kind of scary. We are executing this Lambda as like a 60, at least 60 times per hour. So just imagine that you are on a business where your core business, I don't know, let's say that you sell food and all your orders are placed in the morning between 10 a.m. and 1 p.m. So after that time, your orders are going to decrease, I don't know, let's say from 500 to 1,000, from 1,000 to 50 or 20. So it's not good at all to have this Lambda running all the time, processing and looking for orders each minute when you probably are not going to have any. So the question is, how can we escalate this in a way that is going to work according to our needs? So there are a few ways to solve this problem, but the one that I want to put on your mind right now and to start thinking about this. So this is our architectural diagram. So what if we do something like this? So instead of having a worker in here that is scheduling all the time for the orders, what if we put a broker? So that this broker will only check how many messages are on the queue, and based on the number of messages, is going to execute n numbers of Lambda workers that will satisfy this demanding. So this will be some sort of auto scaling group that we, and since these are not easy to instance, it will work on the same fashion that with our Lambda function. So let's see how that works. So first thing we need to do is to define our broker. So let's define here our broker, and this is going to change a little bit. So this worker is not going to respond to any event at all. So we just can get things out of here, and let's put the handler in here. It's going to be our functions, and it's going to be our broker, that handler. And this is the one that is going to respond to the event. And let's put in here this rate from 1 minute, but also consider that into this broker, you can change this data dynamically. So you just can literally save stuff like, okay, 10 p.m. just change this to each 5 minutes, and after 1 p.m. just change into each in an hour or 2 an hour. So you have these CloudWatch events available, and you have specifically this scheduled expression event. We are not going to do that at this moment, but I will put it on your mind to think about it, how to orchestrate better software architectures. So let's put in our environment. By the way, if you are interested in knowing how to do that, just let me know. I will put a video on that. I will be happy to do that. So I will need all these variables that we are using here as well. And let's define them. Since we're going to run several Lambdas, let's say how many workers do we need at the moment. And this is not going to use want to use anyone. So, but I need to pass the Lambda, the name of this Lambda. So the name of this Lambda is going to be like serverless introduction to SQS, because that is my service name, and then it's going to have the stage, which is development, and then it's going to have the worker, which is the name on this. But this is long as fuck, and I just don't want to do it this way. Let's put it, use our variables here. So self service, and this is the service name, and then we can say self custom that stage, and lastly we're going to put the worker. So now it's more elegant and it looks better. So the amount of workers, let's say the jobs that is going to run, let's say that the default is going to be 5. I don't know, you just can make this assumption based on the time that you know that your worker is going to take to process one order. So let's create our broker to see how that will work. Okay, so the only difference that you will see in our worker will be that right now we're executing Lambda. So you will learn in here how to execute a Lambda from another Lambda, which is a pretty cool trick. Well, it's not trick, it's available on the SDK. So let's see how that works. So first, let's pull in message from, let's put in here Q URL. And then we just can say our params are going to be, I don't know, our check params, because we're going to be checking, and our Q URL, this is capital Q, and it's going to be our Q URL, and the attribute names that we're going to require is going to be approximate the number of message. So this is, as the number implies, is going to tell us approximately how much message are in the queue, so we can make decisions in there. So this is going to return object that have an attribute props. So let's do SQS get Q attributes, and we're going to pass check params, and this is going to return a promise. So all these methods you can find it in the AWS SDK documentation. I'm just going to include it on the resources for this tutorial. And lastly, this is going to return us this property here, the and this is going to get from attributes. So we can say something here like console log. So message in the queue. Let's put it. Always log your stuff, because later you, based on the on checking how your system works, you can make better decisions how to optimize your Lambda. One of our next tutorial is going to be about how logging effective stuff. So stay tuned for that. And so I just can say my approximate number of message is equal to 0. Then it's going to return. There is nothing to do in here. If so, also otherwise, I just need to calculate workers needed. My workers needed is going to be my number. But let me think for a second. Ideally, we should do something like this: math round of my approximate number between the job, because the job, as we mentioned before, is the amount of lambda that I'm going to trigger per unit. So, but there is a problem here with this approach. For example, if I do this math round, and let's say if I have one message in between 5 jobs, this is 0, and if I have 2 messages between 5, this is also 0, and it's starting to be 1 only until this is, oh, I just telling this backwards. No, is okay. So in 5, this is 1. So I have, you know what? For the sake of the exercise, is okay. You just make the arrangements if you need it later. I'm just going to say something like approximate number less equal than 2. It's going to be 1. Otherwise, it's going to be the value of this. Let's put this into parentheses so it's more clear what we're doing here. And let's do some console log in here. Console log workers neither approx are workers needed. And let's put in here our logic to execute Lambda. So again, we're going to say let I equals 0 to I s equals to workers needed I plus plus, and we're going to say console log starting workers. So I want to know how many workers are running here. So I need a variable to just say that workers running. We can define this up here. That running, this is going to be 0. So this means that I need to increase it in here. And this means that we need to yield lambda that we have in here, and also need to invoke. And our configuration object is going to be function name, and it's going to pass the worker, because we pass the worker as a name of our function. And our payload is going to be nothing, because our worker is going to be directly to the queue. So let's put null in here. So, and this is going to return a promise. And that should be it. So let's make sure that I did everything proper. attribute of checking the grounds, approximate number of message, that should be okay too. So all this part, it looks fine. Now we need to put some permissions in here. And we just want to say that our lambdas are need to invoke functions. This is getting out of control. On the next video, we're going to solve this because this is getting ugly. Ideally, we should have permission per each lambda, so we basically have control over what each resource is using. So okay, so let's see what we're going to do here. So what we're doing here is that we have our broker that is going to run each 1 minute, but depends of the number of the messages that are on the queue. We already know that how much message can our worker handle. We say that for the sake of example, it's going to be 5. So based on that, we are going to start invoking lambdas to kind of process all that order easily. So this will be like scaling our lambdas. And what I mentioned before, notice that you can also set that to 1 minute, but in some moment here, you can say that if time of the day is equal to 10 a.m., just change that rule because you have that access to this expression in the CloudWatch events SDK. You just can change it to 1 per minute or half an hour or 1 an hour. So that is totally up to you. So you know what? Let's deploy this to see how this goes. Okay, I've deployed this, so let's see how our broker behave. It should be starting for executing soon. Okay, start. So perfect, there is no message on the queue. This means that this didn't start. Okay, so let's start kind of putting some message in there. Let's say if I come here to our seats, and I already passed 25 orders, so node seats. So the orders are having copy. Let's see if we have our events in the DynamoDB. So yes, there are events. So if we come to our SQS, we have our 25 events. So let's see how this behaves the next time that it just starts pulling for data in here. It's going to be, as you can see, start already working. So let's see what. Okay, nice. See how this works. Message in the queue, start 5 workers because we definitely see that we could handle 5. 1 worker could handle 5 events, and if we come here, it will be process all the orders. And if we just come back to our DynamoDB, we just come and see everything was completed in less than 1 minute. So the next time that this is going to run, it's going to be nothing. I'm just going to pause the video and wait until the next iteration just comes in. And nice, the next time we didn't start any worker at all. So that's it, guys. That's how you can scale your queues using Lambda functions, using the super cool serverless framework. Please, if you find this interesting and you are interested in more content like this, please subscribe to this channel. I will keep publishing videos and all about cloud stuff and serverless stuff. And I know it was a fucking long video, but well, it was worth it. On the next video, we're going to keep extending this feature, but we're going to use step functions to notify the users via email when their orders are finished. So stay tuned. Thank you for watching.